Hello, welcome to another briefing. So in this briefing, per usual, I'm going to start out with the Northeastern Pacific satellite image. And I want to show you here our next storm system for the Bay Area and California here. And seeing this thick, bright clouds here, that indicates very high cloud tops. These are convective type clouds. These look a lot like cumulonimbus on the satellite here, so there is even some potential thunderstorm activity with this system. You can see the front pretty much right over here. Make out that classic cold front, and then here's that surface low with the spinning motion. It's actually you can see that kind of cinnamon bun appearance with that dry air, the dry conveyor belt, the dry air wrapping into the system, forming that comma-like shape. A lot of cold air behind this. You have a lot of the scattered, puffy, fair weather cumulus clouds that indicates a very cold atmosphere aloft. So there's that cold air. And then you have, if you were to draw out what the jet stream is doing, you have the jet stream doing something like this. Big trough out over the Pacific about to make its way in. And then you have a ridge over most of the western United States that's going to start to break down. I'm going to take a look at computer model guidance here. Okay, sorry. Did not have that preloaded. Here we go. So, start out initializing this model. This is started at 4 a.m. today. This is the deterministic run of the European model. Ideally, one should look at several models, as I did, but I didn't want to go through all the models, and it would just take a lot of time to do that for this video. I already did that previously. The European tends to do pretty well. I tend to look at the European, but if you want to do your due diligence with forecasting, it's important to look at different models and also look at ensemble guidance. But I'm going to just look at the Euro deterministic, and we're noticing pretty much exactly what we were seeing on satellite. There's that trough out over the ocean. Jet stream is doing something like this. And you have, of course, our surface low out here that we saw on the imagery. You have your cold front right here. You have a warm front up here, roughly into the Pacific Northwest. And then you have an occluded front somewhere around here. Now, just for the heck of it, to see how accurate this is, I'm gonna look at the official surface chart from the Weather Prediction Center for this morning and see if I was correct. So here's the 12Z. I mean, pretty much you got that warm front up. It's a little further south than I thought, but I mean, actually, if we go, yeah, okay, if we go to currently, based on the satellite, the warm front is now progressing from the coast of Oregon into the coast of Washington. The cold front is starting to approach the California coast. And one thing that's interesting to notice here as well is you have these tightly packed isobars, which indicates there's a tight pressure gradient, which is going to pull a lot of south wind ahead of this low pressure center. In the northern hemisphere, you have winds generally flowing counterclockwise around low pressure centers and clockwise around high pressure centers. So you're gonna have you should expect quite a bit of southwest wind over the California coastline in the next 12 to 24 hours. So now let's go further into time with this model projection here. So here's tonight into tomorrow. Expect some rain and wind. Still some lingering showers into tomorrow. Snow levels will start out probably above pass level tonight, and then quickly dropping tomorrow, maybe down to, I want to guess, 5,500 feet or so. If we take a look at the temperature cross-section prediction here for Sacramento, for instance, which will work for the Tahoe area, I'm going to draw the freezing layer, I'm going to draw what we would call the melting layer, which is when the most of that snow would be melting into rain, and what the estimate is per this model projection as we go through the next few days. Because even like a few degrees below, above 0 Celsius, up to about 4 Celsius, you can usually still get snow. So I'm going to draw what the freezing layer and consequence rough estimate of the snow line would be through this time frame. And so by the time we get into roughly Sunday morning, you could, at this 850 hectopascal level is roughly 5,000 feet. So you could get a 5,000-foot snow home once you get to Sunday, maybe into early Monday, but this is 10,000 feet up here. So this kind of gives you an idea. It could be 6,500, 5,500 maybe on Sunday. And so sorry about that. That was my cell phone alarm. I apologize. And then as we go through the next few systems, it could be colder. I'm going to show you this on the guidance, but I mean, there's a system coming in roughly the 8th and the 9th, and snow levels with that system could be as low as 3,000, maybe even flirting with 2,500 feet here. So, something to watch. Let's go ahead and pull up that guidance now. Here we go. So here's that system into Sunday, and then Monday, Tuesday. And then look at that system. It starts coming in Wednesday. Go into Thursday. There's not a lot of moisture with it. There are a couple waves of precipitation here. And this is where we could see the snow level maybe down to 3,000 feet. Unfortunately, albeit the more available cold air, the track of this system is more out of the northwest, so it tends to not pull as much moisture ahead of it as systems that are coming from the west or from the southwest. And this kind of pattern does not favor a ton of precipitation. See, because winds out of the system are more west instead of southwest, and I mean, you get colder air, but the downside is that a lot of times you don't really get the moisture linking up very well. So maybe some snow showers down to 3,000 feet, but I wouldn't expect much based on this particular run. That could still change, but this particular model run isn't really bringing us much. And then just not really seeing a favorable pattern after that. We're seeing mostly ridging here. So this would dry things out again after, pardon, I have to change that. So here's the next few systems, okay? Here's Saturday. Here's that wave that goes by. Here's Sunday. We get a pretty wet pattern for a few days. And then here's Tuesday. Here's that colder system Wednesday into Thursday. And see, here's where I want to show you the difference. The system on Sunday and Monday, for instance, it's pulling more wind out of the southwest, which is going to give more, it's going to bring more moisture from the tropics. The system after that, if we go forward to this next wave here, Wednesday into Thursday, this next couple waves really, because I'll show you. There's one wave here, little ripple in the heights. It's a short wave trough. There's another one right here. It's following it behind. So these are pulling winds more out of the west northwest. The flow as these come in, it's a lot drier. It's not really pulling in that deep tropical moisture. And I can go ahead and show you what I mean by looking at moisture in the column here. And you're gonna see the difference here. So the Monday system, look at that. Look at that nice moist flow from the southwest. You can see it on this animation. And then we're gonna look at the next system, see it's more west, maybe west southwest at best, and it's just not a lot of water. See, look at this. Look at these greens. Look at these darker green colors. Look at this. It's pretty moist. And then you're gonna look at the next one, and it's not that much. It's light blue at best. It's not a lot of moisture. So let's go back. You can see here, I'm gonna show there's wave number 1 Wednesday, and then there's wave number 2 passing the Bay Area, but more inland. So this might be more of a light snowmaker for the Sierra. And then it wants to build this big ridge, and we don't really, snow lovers don't like ridges, and even wet weather lovers, because they tend to block the systems. They create what we call a blocking pattern, and that forces all the storm systems to the north, trying to come in from the Pacific, and they get deflected way up into either the Pacific Northwest or sometimes way up into Canada. And then you have cold air on the backside, but these storm systems get deflected. The storm track goes way up to the north, and then it can drop into the Intermountain West, and they can get what we call inside sliders. But for California, this is not a favorable pattern. And you can see here, as we go through here, there's the 7th, there's the 8th. There are those inside sliders. Good snow for the Intermountain West, maybe even Sun Valley. If it's more of a west flow rather than northwest, they could actually get some decent snow on the 7th. And then on the 8th, just a tad too warm for snow in places like Seattle and Portland. If you want that, you would ideally want to see this 522 thickness line down to Seattle, and that's not what we're seeing here. It's still just a little too far north. If I put this into motion, we're gonna put the actual heights here. See, the key is you want to see this blue. You want to see these blue, this shading of blue, make its way down here for you to get snow in somewhere like Seattle or Portland. You need to bring this colder air a little further south. And unfortunately, this guidance keeps it just a tad too far north. I mean, maybe to get a snow rain mix down to sea level at these places, but I think snow level is probably going to hang around 2,000, maybe down to 1,000 feet for some areas. At this point, it's just really not looking quite cold enough to get sea level snow, but we'll keep an eye on that. And this ridging pattern is kind of a bummer, because we would really want to see a different kind of pattern set up if we wanted a deep cold or cold storm situation. I'll show you what the 0Z run had. See, if that were to play out, you would have this ridge eventually becoming positively tilted, as we call it, into British Columbia and northern Canada here. You can't see it, it's sort of out of frame, but this ridge would become positively tilted, which would force a positively tilted trough to dump cold air straight from continental Canada into the west coast of the U.S., which will include places like California, the Bay Area, and such, with winds going straight north, just spilling in. That flow, just you can see the flow here, just spilling in that fresh, cold air way into the west coast. In order to get that, we would need this specific sort of pattern. I can zoom out here in the North American view, because that's what we want. We need this ridge into Alaska, but tilting up this way so we get the positive tilt this way. But this is a one projection way far out, and as expected, the next full run after this, completely different setup. The ridge is it's way further south, and it's not really bulging up much here. It's not tilting, so that cold trough, it's into the East Coast. Midwest and the East Coast get that really cold air. Because you need this to bump up this way for this to do this, but that's not what's happening right now. So it's really gonna depend on how this upper air pattern sets up. And here you go even more zoomed out. You look at the northern hemisphere as a whole, like from the top down, looking down. You have the North Pole here, and you can see this big blocking pattern, this big blocking ridge over Greenland, which is forcing a lot of cold air into Europe and into the northeast of the US here. And then this is actually a projection for next week. It would force, or sorry, this might actually be for the next few days, but it's forcing a trough into the west coast as we were looking at as well. But exactly how all of these set up play a huge role in who's going to get what kind of weather. If this, for instance, if this ridge here nudges a little bit further up this way, we get more of a positively tilted trough. We get that deep cold. So it's really just small little changes that can happen, especially when you're looking far out. Any small little change with this pattern could bring us that deep cold, or it could just bring us even warmer weather if this ridge makes its way further south, or it could bring us very wet weather, a very continuously wet pattern if it kind of stalls in a position where it's just bringing a consistent moist flow to our area. So there's a lot to watch with how this moves around and how these larger scale patterns set up. Anyways, before I get way too into the weeds, I just wanted to thank you for watching this. I hope you got something out of it, and I'll see you next time.